Howdy, howdy, and welcome to day 19 of our logic curriculum. Today we're going to be reviewing for our final exam tomorrow. So we're going to be going through the review that was passed out in class, and we're going to go ahead and begin now. The first part of the test is dealing with matching, and there are two pages that we've dealt with almost exclusively in this class that have done most of the material we're looking for. The page 11 and page 23 have been the pages that deal the most with what we've been talking about in class. Page 11 dealt with our logically equivalent statements, and page 23 dealt with our implications. And so a lot of the symbols are going to be found on those two pages. So let's go ahead and talk through this. Remember, the logically equivalent was one of our definitions, and the symbol for logically equivalent is on choice G. A conditional is something we've dealt quite a bit with in this class, and its symbol is choice K. Conjunction is choice E. A disjunction is choice F. An implication is choice D. Remember, we always changed that to a conditional and had to make it be a tautology. For our universal set, which for some reason is not showing up on the screen, that should be choice L. And existential is choice M. A negation is the tilde, which is choice H. Intersection is choice A. Union is choice B. Complement is the cursive C, which is choice I. A subset is the special symbol for choice C. The empty set was a circle with a line through it, and that's choice J. And so that takes care of our symbols that we've dealt with in this class. But we also had several logically equivalent statements and implications that we've had to memorize. One of them is De Morgan's law, which says that the negation of a conjunction is a disjunction, and that's choice N. We also had the contrapositive, which takes a conditional and rewrites it by exchanging and negating the antecedent and consequent, and that's choice R. And we had our three arguments. Modus ponens gives us a conditional and its antecedent, which is choice S. Modus tollens gives us a conditional and the negation of its consequent, and that's choice O. And hypothetical syllogism has two conditionals, which gives us the first antecedent conditional, the second consequent, which is choice T. And then we have these two properties that we've dealt with on page 23. The idea that for a conjunct and also for a disjunction, the order of the terms really doesn't matter. It does matter for a conditional, and so for conjunction and disjunction, we have this commutative property. We also have this associative property in that it doesn't matter in which order we do things first. I can do the last two disjunctions or the first two disjunctions. For conjunctions and disjunctions, the order doesn't matter how we group them either. And that's why choice Q is the associative property. So for our first 20 questions, this is how the matching should go. G, K, E, F, D, L, M, H, A, B, I, C, J, N, R, S, O, T, P, Q. And of course, page 11 and page 23 have all of these statements that we've been dealing with all year. The next part of the review is dealing with writing statements in symbolic form. So we've got these first basic statements that we learned the first week of school. If Sam goes to the store, she will buy some pretzels. That's a conditional. With Sam going to the store being our antecedent and buying some pretzels being our consequent. Karen will go to Schlitterbahn and Jenny will drive her there. That's a conjunction. With Karen going to Schlitterbahn and Jenny driving her there. There will be a cancellation of school, or everyone will go to school, or is the key word for a disjunction, where we're talking about a cancellation of school or everyone going to school. And we have Doritos will taste funny if and only if there's a problem at the Frito-Lay factory. If and only if it is the symbol biconditional. Those are the keywords for a biconditional. And I'm going to have Doritos will taste funny if and only if there is a problem at the Frito-Lay factory. So these first four should have been pretty simple because they're from our first week. The next page deals with some of the quantified statements. So I have no binder has paper in it. No is a universal, so I've got universal X. It is a binder. It just does not have paper in it. So that's how it would write. Notice that the negation only goes on the second predicate. It never goes on the first predicate. For 26, I've got some person is president of the United States. That's going to be an existential. And because it's an existential, it has to be a conjunction for some person, PX, and president of the United States, let's call that UX. Not all swimming pools particles are chlorinated. This is also an existential. But because I have that negation in there, the second term is what gets negated. So we're going to put negation CX. And we're talking about swimming pools, so that's SX. And for 28, all students should get this problem right. That is a universal. And students, let's call that SX, conditional problem PX. Now, the actual letters that you choose for the predicate are not important. And notice that I have repeated some letters for different questions. That's perfectly acceptable. But if you want to, you can choose whatever letters you want. I could use F for this first letter, and I could use N for the second letter. It has nothing to do with the statement, but it's still going to be correct. So that's 25 through 28. On 29, I've got Charlie is a student, so I've got a subject, Charlie, and I've got a predicate, is a student. And if I'm going to write this in predicate form, is a student is my predicate, and my subject is Charlie. And then on number 30, since I'm talking about a subset, that's this long C that we're talking about. Some books will put the underscore on it before we want to know if we're talking about a proper subset or not. That's what that depends on, but that's beyond the scope of what we've been talking about. The set of cars, I'm going to let a capital letter C represent the set of cars, and I'll let a capital letter V represent the set of vehicles. And so this would be writing this in symbolic form. And so that's 1 through 30. Of course, we're dealing more with these symbolic forms that we learned for right before our Chapter 2 test and what we learned earlier this week. There are 4 proofs on this test, 2 of them with truth tables and 2 of them with 2-column proofs. Here's our first of a truth table. I want to prove the statements are logically equivalent, which means I want to prove that the left side has identical truth outcome to the right side. So I need to do a truth table for both of these expressions and show that I do get identical truth outcomes. So I have 3 statements, P, Q, and R. So I have true, 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 false, 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 false. For my first column, true, true, false, false, true, true, false, false. And for my third column, true, false, true, false, true, false, true, false. So I have 3 statements in this, and I should have 8 rows in my truth table. And one of the things we talked about is how we use our parentheses first. So I have a Q disjunction R. A disjunction is a statement that is only false if 2 given statements are false. And I'm comparing Q and R, so they're only false in the 4th row and the 8th row. Everywhere else is true. When I do P disjunction Q, that's only going to be false in the 7th and 8th row. And when I do P disjunction R, that's only going to be false in the 6th and 8th row. So that takes care of all of our parentheses. But I want to take care of the left side of my expression, which means I'm doing the conjunction of P with Q disjunction R. And a conjunction is a statement that is only true if both statements are true. So when I compare these 2 columns, I notice in the first 3 columns, they're both, the first 3 rows, they're both true. The 4th row I have a false, and 5, 6, 7, 8 I have a false. So I'm only going to have 3 trues and 5 falses. So this is my left side of the expression, and I want to compare it to the right side of the expression. My right side of the expression is I'm doing the conjunction of this statement with this statement, and in this case I've got 5 trues before I have a false in the 6th row, a false in the 7th row, and a false in the 8th row. So if I do P disjunction Q with P disjunction R, I actually end up with 5 trues and 3 falses for the right side. And these are not identical truth outcomes, so they're not logically equivalent. Remember that if we're trying to prove statements are logically equivalent, we need to show that 2 columns have identical truth outcomes, which we just don't have here. On problem 32, we're going to be doing truth table argument. And remember that in order to do a truth table argument, we have to list our premises and then write our argument first as an implication, and then second as a conditional that we want to be a tautology. So we have, if Jeremy goes to the basketball game, let's say G for go, he will buy a box of popcorn. Let's use B for buy. That's my first premise. My second premise says if he buys a box of popcorn, he will spill his box of popcorn. Therefore, my conclusion, if Jeremy goes to the basketball game, he will spill his box of popcorn. So if he goes to the basketball game, he will spill his box of popcorn. So I'm going to write this out as an implication. Remember that an argument is an assertion that the conjunction of two or more statements, called premises, implies another statement called the conclusion. That's supposed to be an S, not a G. Now, at this point, you should recognize this is really a hypothetical syllogism argument. And so this will end up being valid. That's one of the advantages of having memorized those three arguments. But we still need to prove that it's true using a truth table, because that's what the instructions tell us to do. So I need to rewrite this as an implication. So I've got my G conditional B conjunction B conditional S. That is my antecedent. I want to change this to a conjunction with G conditional S. And I want to say this is a tautology. Remember, a tautology is a statement that is always true. And so ideally, when I go through this process, I want to get a column that is all true at the end. So I have three statements here. I've got G, I've got B, and I've got S. And of course, we're so used to doing these truth tables. True, 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 false, 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 false. True, true, false, false. True, true, false, false. And then I've got true, false, true, false. True, false, true, false. I don't have any negations here, so I want to go ahead and start with my parentheses. I've got G conditional B and a conditional is a statement that is only false if the antecedent is true and the consequent is false, and that happens on the third and fourth rows. I've got B conditional S, and that's going to be false on the second row and sixth row. And I need to do G conditional S, and that's going to be false on the second row and the fourth row. And I want to take the conjunction of these because my antecedent is the conjunction of G conditional B and B conditional S. And a conjunction is a statement that is only true if two given statements are true. That happens on the first row, the fifth row, the seventh row, and the eighth row. So I'm going to have T, F, 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 T, F, T, T. And this is my antecedent. My consequent is the statement that we just had, G conditional S. So I'm looking for my antecedent is true and my consequent to be false. That's when an argument is invalid. There are only 4 spots where my antecedent is true, but on those 4 spots, my consequent also happens to be true. So when I do bracket conditional B conditional S, I find that all of these end up being true. And this statement is a tautology. And so this is valid. And so the student will be expected to prove an argument using the truth table method that we talked about in the second week, but we'll also need to prove an argument valid or invalid using the 2-column proofs, which we talked about later. And that's our next example here. For our 2-column proof, we have problem 33. Rudy drives a car, or Rudy drives a truck. If Rudy's insurance rates are too high, Rudy won't drive a truck. If Rudy is an unsafe driver, Rudy's insurance rate will be too high. Therefore, if Rudy does not drive a car, he is an unsafe driver. He is not an unsafe driver. So negation U. So these are my premises. And my conclusion. So we're going to start our two-column proof with our statements and reasons. And I'm going to list my three premises. I've got C, disjunction T. I've got I, conditional negation T. And I've got U, conditional I. These are all premises. And the first thing that caught my eye when I was reading this was the word or. The thing is, when I see that word or, I'm thinking to myself, hey, that's a disjunction. I can't use disjunctions in a two-column proof. I need to change it to a conditional. And the tool we have to change disjunctions to a conditional is denying the antecedent. So I want to do denying the antecedent on step 1. That's going to make my antecedent negation C, and my consequent stays the same T. That uses up statement 1. And now I'm ready to start putting two statements together. And in putting two statements together, I notice that I have two letters here that are the same, I. And so I'm going to put those two letters together. So I'm going to have U conditional I and I conditional negation T. And so when I do the conjunction of 3 and 2, that's a hypothetical syllogism. And that's going to give me my first antecedent conditional, my second consequent. And that uses up statements 2 and 3 for the conjunction, and statement 5 for the hypothetical syllogism. This is not my conclusion. My conclusion involves a C and a U, and I don't have this U in the right spot. It's not in the right spot, and it needs to be negated. And if I look at my other statement, negation C is already in the right spot. I really like that negation C being in front. So I need to change this so that the U is in the second term and it's a negated term. So I need to do something that's going to exchange and negate my antecedent and consequent, and that's contrapositive. Now, when I do the contrapositive on step 6, that's going to give me a regular T conditional negated U. And this term goes very, very well with step 4 because those T's match. So if I put statement 4 and statement 7 together, negation C, conditional T, and T conditional negation U, the conjunction of 4 and 7, which by the way uses up statements 4 and 7. This is also a hypothetical syllogism. And that's going to get rid of my middleman here. It's going to get rid of T, giving me negation C, conditional negation U, which is exactly what I wanted. So this is a valid argument. So in this case, I had a couple of things I had to take care of. One, because I had that disjunction, I had to use denying the antecedent to get it to look like a conditional. And second, because this was in the wrong order, because U needs to be a consequent, not an antecedent, I had to use contrapositive to take care of that. So that's the first of our two column proof problems. Our second two-column proof problem is dealing with universals. So I have all hairy creatures need to use a comb. That's a universal X. They are hairy creatures, and if they're hairy creatures, they need to use a comb. And I say that all cats are hairy creatures, so that's a universal X, and I'm dealing with cat. I'll use K for cat since I already used C for comb. Conditional HX. And I've already got an idea in my head what I'm going to do. But I say Fluffy is a cat. And remember that I'm using the letter K for is a cat, and my subject is Fluffy. So these are my three premises. And I want to conclude that Fluffy needs to use a comb. Need to use a comb that's C, and Fluffy is the subject. So I've got these universal statements. So I'm going to go ahead and start listing my statements and reasons. I've got universal x, hx, conditional cx, universal x, kx, conditional hx, and k fluffy. And these are premises. And we notice that whenever we're dealing with a universal, what we need to do is change it to a particular subject, not some generic, undefined variable subject, but we want to talk about fluffy. So instead of saying hx conditional cx, I really want to talk about h fluffy conditional c fluffy. And that's instantiation. So I'm doing instantiation on 1. And that's going to use up statement 1. And I need to do the same thing on statement 2. So instantiation on statement 2, and that's going to give me k fluffy conditional h fluffy. And at this point, I'm ready to start putting statements together. I've got 2 conditionals to choose from, and I'm going to go ahead and choose statement 5 first, and I'm going to put 5 with 4. So I've got k fluffy conditional h fluffy and h fluffy conditional c fluffy. And that's the conjunction of 4 and 5. This uses up step 4 and step 5, and this is a hypothetical syllogism argument because my middle terms match. So I'm going to have k fluffy conditional c fluffy. And that's by hypothetical syllogism. So that uses up statement 6. This is not my conclusion. So I need to keep going, and I only have two statements left. I've got statement 7, and I've got statement 3. And so I'm always put my conditional first. So I've got K fluffy, conditional C fluffy, and K fluffy, and that's the conjunction of statements 7 and 3. And that's a modus-ponens relationship. And modus-ponens is going to give me C fluffy. And so I end up with a valid argument. So the key here on this problem is because I see this universal, I need to go ahead and do an instantiation. I need to do an instantiation for each one of our universal quantified statements. So now I want to deal a little bit more with the sets that we've talked about most recently. I've got a universal set that includes Kawasaki, Honda, Harley Davidson, Indian, and Motobakan. I've got several sets here, and I need to figure out what the operations are. So I've got A union E. Remember, a union is a set that contains all elements found in either set. So it's going to contain everything that's in A or in E or both. So I'm going to have Kawasaki, I'm going to have Honda, I'm going to have Motobakan, and I'm going to have Harley Davidson. And so this set is the combination of those sets that we've dealt with. I've got B intersect C, and intersection is a set that contains all elements found in both sets. So I want to know what's in both B and C. And looking at this, only Harley Davidson is in both of these sets. So I'm going to have the set that contains Harley Davidson. On 37, I want the intersection of C with D. In other words, whatever's in both C and D, and only Honda satisfies that. So I've got the set containing Honda. On 38, I want to know, is D a subset of A? In other words, is every element in D findable in A? So is Kawasaki in A? Yes, it is. Is Honda in A? Yes, it is. And so every element in D can be found in A, so the short answer is yes, these are subsets. D is a subset of A. On 39, I'm looking for the complement of B. That's a complement is a set that contains all elements not found in a given set. So what's missing from B? Well, Kawasaki is missing. As is Honda. As is Motobukan. Now, I would be perfectly fine if I was to put set A here, because set A is the set that contains only those elements as well. So either of these would be a perfectly acceptable answer. And the last simple set problem we have is C minus D. I want to find the set subtraction. It's all the elements that are found in set C that are not in set D. In other words, I want to take set D away from set C. So I want to take Kawasaki out of set C, which isn't a problem because there is no Kawasaki in set C. I also want to take Honda out of set C, and so I need to strike it from it. So all I have left is Harley Davidson and Motobukan. So these are our set operation problems, dealing with the terms that we talked about in class this past week. The last part of our test deals with Venn diagrams. So I have all of this information that I need to put in a Venn diagram form. So looking at this information, I have three different sets that I'm dealing with. The set of teachers who've watched Iron Man, the set of teachers who've watched Transformers, and the set of teachers who've watched Hulk. So I need to come up with a Venn diagram that represents these three groups. So I'm going to draw one circle that represents the teachers that have watched Iron Man. I'm going to draw one circle that represents the group of teachers watched Hulk. And I'm going to draw a third set that represents the teachers that have watched Transformers. And I need to figure out where this data is going to go in these three sets. So let's take a look at the data. And in class we talked about how we're always going to start with our center piece of information, the center information where all three sets overlap. And we know that there are 43 teachers who have watched Iron Man, Transformers, and Hulk. So our center region, where all three circles overlap, is 43. So for the 330 information, these are the teachers that have watched Transformers and Hulk. Transformers and Hulk are going to be these 43 students plus these students, which we have no idea how many there are. But I do know that they have to add up to 330. So if I subtract 43 from that total, I end up with 287. And so there are 287 teachers that fall into this category. The ones that have seen Transformers and Hulk, but did not see Iron Man. And if I do the same idea with the 223 who watched Iron Man and Hulk, I get this piece of information here. The 223 minus the 43, which gives me 180 teachers who've watched Iron Man and Hulk, but haven't watched Transformers. I'm going to do the same with this 419, subtracting it. And that's going to leave me with 376. So this allows me to find out these overlapping regions. So now I need to determine what happens in these non-overlapping regions. In other words, this region here, where the people only watched Hulk. I know that this whole circle has to add up to 761. But I know that I've already got these three pieces here adding up to 510. So if I take 510 and take that away from the 761, I end up with this number of how many just watched the Hulk, which is 251. For the 1164 that watched Transformers, I need to take away the 376, the 43, and the 180. In other words, the whole 599. Excuse me. Not these, the Transformers, the 376, the 43, and the 287. This is 706. And that's going to leave me with 458. 458 people that just watch Transformers and not any other movie. And I do the same thing with the Iron Man 1227. So when I take 1227 and subtract 599, I end up with 628 that watched just Iron Man and no other movie. And I've got 7 regions here, but remember that when I have 3 Venn diagrams, it's just like having 3 statements in a truth table. I need to have 8 regions, and this region over here represents the people who watch none of the movies. Well, if I had 2,837 people, and all together in the 628 and such, I've accounted for 2,223 people. I'm going to end up with 614 people that don't fall in any of these circles. 614 people that have watched none. I have to be careful and not add up 1227, 1164, and 761, because I'll end up with more than 3,000 people. That's because some of these people are counted twice, and 43 of them are counted 3 times. So now that I've prepared my Venn diagram, I can get rid of this scratch work, and we can talk about how to answer these questions here. So for our questions, it wants to know how many of the teachers watched none of the 3 movies. That's this none that we put in the corner down here. This 614. It wants to know how many of the teachers watched only the Hulk, and that's this 251 that are in the Hulk circle but aren't in any other circle. And if I combine the 251 who watched only the Hulk, the 628 which watched only Iron Man, and the 458 which watched only Transformers, and I add those up, I end up with 1,337 people who only watched one of the 3 movies. So even though the question 44, which tells us to draw the Venn diagram, is our last question on the page, that's so we have room to answer the Venn diagram, to use that information to answer questions 41, 42, and 43. This review is very similar to the final exam you're going to see in class tomorrow, so this is an excellent tool to review. It's going to prepare you very well, and it covers everything we've done over the summer. appreciated teaching you. I hope you've got a lot out of these videos, and I do thank you for watching. So this is Mr. Potter. Thank you very much for watching.